Here we'd like to solve a complicated equation involving fractions using a technique called clearing the denominators. So whenever we have an equation, we can do something to both sides equally in order to transform the equation. So what I'm going to do here is I'm going to multiply by a factor of my choice on all sides to all terms. Now the right thing to choose actually comes from the denominators that we see currently in the problem. So notice that some of these have a x plus 3 as their denominator. So we can actually approach this problem by multiplying both sides by that denominator of x plus 3. How it works is you put both sides in parentheses, and then on the outside here you introduce a factor of your choice. In this case I'll do x plus 3. Now the reason why this factor works really well is it's going to cancel with some of the x plus 3's down below. We do have to distribute it to both terms though in this left side. Okay, so the thing that I'm introducing is in red here. What's in black was just the original equation. What'll happen is these will cancel and these will cancel, leaving us with a new equation of no denominators, which is nice. Now we just want to solve this equation as normal. So we'll want to distribute the 3. We'll get 3x plus 9. We'll distribute that negative 5. Get negative 5x minus 15. We want to get the x's together. So let's add 5x to both sides. And we want to get the 9 away from the x's. So I can move the 9 to the right. This will give us 4x plus 3x plus 5x, which is 12x. And over here we'll have negative 24, it looks like. So our final answer becomes x equals negative 2. Now we should check our solution, so plug the negative 2 back into the original equation just to verify that it really does hold true. Let's see. It does check. So now we know that negative 2 is the correct solution to that equation. All right, let's try a couple more here. Our denominator is x minus 3 for 2 of these terms, so let's multiply all sides by x minus 3. We'll get 3x equals 2 times x minus 3 plus 9 after we distribute this and cancel it. we'll have 3x equals 2x minus 6 plus 9. Looks like we'll have x equals 3. So we want to check the solution just to verify that that really works and there's no problems with it. So plug in a 3, and looks like we do have an issue here. We'll have 9 over 0 equals 2 plus 9 over 0. So that does not check. And the reason is division by 0 causes each side here to be undefined. So we can't say that that solution is valid. So cross it off. Say that it does not check. And therefore, we'll say there's no solution to this equation. Alright, here we'll multiply all sides by x plus 2. Let's see, we'll have 2x minus x plus 2 times 3 equals negative 2. 2x minus 3x minus 6 equals negative 2. Negative x equals 4, therefore x is negative 4. Let's check and see if x equals negative 4 works as a solution. So we would have 2 times negative 4 over negative 4 plus 2 minus 3 equals negative 2 over negative 4 plus 2. Negative 8 over negative 2 minus 3 equals negative 2 over negative 2. So we'll have 4 minus 3 equals 1. It does check. Good. In this next one, we see that we have different denominators. So we're going to want to determine what the least common multiple of those denominators is. And then we'll want to multiply all sides by that least common multiple that we find. Now, one of the ways to get a common multiple is to simply multiply all the denominators together. So we could come up with a common multiple just by the product of a times a plus 1 times 2. That's always an option. We could use more rigorous methods just to make sure that it really is the least common multiple, but it's not really necessary to do. So we can use that. Let's multiply all terms by this common multiple that I found. So the problem was 1 over a plus 1 over a plus 1 equals 3 halves. And I said that the common multiple of the denominators is a times a plus 1 times 2. It's just the product of all three of them. So we'll multiply a times a plus 1 times 2 here, and a times a plus 1 times 2 here, and do it here as well. The goal is to clear the denominators so that we don't have to deal with them. So the a in the common multiple will cancel with this a. The a plus 1 in the common multiple will cancel with that. And we'll cancel these 2's. This will leave us with a plus 1 times 2 times 1 plus a times 2 times 1 equals 3 times a plus 1. We'll distribute here. 2a plus 2, 2a, 3a squared plus 3a. Alright, we'll try to group the like terms together. I see that we've got an a squared term though, and a single power of a as well. So we may have to use quadratic formula or factoring to solve this eventually. Anyway, let's get all the a's onto the same side. So we'll have 2 equals 3a squared minus a. Let's even move that 2 over as well. We'll get 0 equals 3a squared minus a minus 2. And it's a quadratic now. So we'll use our techniques of either factoring or quadratic formula to finally determine what a must be. I believe this will factor, and we can use -2 and 1 or -1 and 2. I believe we'll want -1 and +2 because we'll have 3a squared plus 2a minus 3a minus 2. That works perfectly. Now we use the zero factor law. Since the product of these factors is 0, it must be that either 3a plus 2 is 0 or a minus 1 is 0. We can solve here. A could be -2/3, or a is 1. Now we have to check our solutions to make sure that they work. Maybe one of them will work, or both of them, or maybe none of them will work. So the original equation was 1 over a plus 1 over a plus 1 equals 3 halves. Let's plug in the 1 first. That's the easier of the two. One plus 1/2 is 3 halves. That's true. So we know a equals 1 is a valid solution. Now let's try the -2/3. Okay, we've got some complex fractions here. We have 1 over a fraction, so we can actually just flip that fraction, turn it into the reciprocal, it's called, -3/2. Here we'll want to do that addition first, and we'll get just 1/3 there. We'll want to flip this fraction. Okay, so 3 minus 3/2 equals 3/2. That actually checks. So both of our solutions turned out to be real solutions. Great.